Okay, I'm back. What are the chances? Anyway, so we were doing bisecting opposite angles, and we said they do not get bisected in a parallelogram. The same thing's going to be true for the rectangle. So now we are looking at rhombus. Okay, so if we look at the opposite angles in a rhombus, it's a little hard to tell here, but they actually are congruent. Okay, and same here and here. All right, and I believe it's on here. Diagonals bisect the angles of a rhombus. Okay, so you can always get it from that. So I'm going to check that off, bisect opposite angles in a rhombus, and it's the same thing for a square. So if we look at this, these are congruent. Okay. These are all 90-degree angles in a square. It says rhombus and square, but that's because they have a lot of the same properties. However, obviously these are not 90-degree angles, right, in a rhombus. But in a square, they are, so these would each be 45. All right, so we can check off that, bisect opposite angles. In the kite, it's only the one diagonal. You can think of a kite as like a reflection, right? So we could reflect this side over to this side. So that means that these angles are going to be congruent here. These will not. All right, and then the last one, the diagonals are perpendicular. So you can, I hate to say you can tell, but you can go ahead and measure those with your protractor, where you're going to see that they are not 90-degree angles. Clearly with the kite, you have 90-degree angles there because they said it's the perpendicular bisector. That's on this sheet right here. One diagonal is perpendicular bisector of the other, so they have to be right angles. So we can say that the kite, the diagonals are perpendicular, and then it also, you can see it with the square, okay? And the rhombus, these are actually going to be right angles, and that's also on here. Diagonals are perpendicular bisector of each other. So we can check off those. All right, and then the next piece is a proof. Remember, we always have to prove things in geometry. So this is going to be a proof on the diagonals of a parallelogram. So we're given parallelogram GRAM, and we want to prove GP is congruent to AP. So here's GP right here, congruent to AP. So we want to prove that the diagonals bisect each other. All right, and then of course this to MP and RP. So we start off with the given statement, parallelogram GRAM. They tell us that right here, so we can write in given. And then GR is parallel to MA. So GR parallel to MA. And GR congruent to AM. So we can also put in a tick mark to show that they're congruent. So the reason for that is opposite sides of a parallelogram this is hard to write with one hand on the phone. So opposite sides of a parallelogram are parallel, and then I'm going to use tick marks here. Opposite sides of a parallelogram are congruent. There. Okay, and then the next one, it says angle 1 is congruent to angle 4. So we have this and this. Well, if the opposite sides are parallel, then I know I have alternate interior angles here. So that's why alternate interior angles are congruent. And then for 6 and 8, same thing. So here's 6. I'm going to use 2 tick marks there, and 8. You have to make the tick marks look different. All right, so same thing. Alternate interior angles are congruent. So now we can say triangle. A lot of interruptions today. Okay. I actually restarted the video earlier because like I just started over because I kept getting interrupted with the announcements. But I'm not going to do it anymore. I'm too far along. So triangle GPR is congruent to triangle APM. So what I want to do is highlight them. Hold on one second while I do this. Okay, so I have that triangle. And then the other one almost looks like the same color. That's okay. It's just really more about showing the two. Okay, it's slightly different color. So triangle GPR, so the top one, is congruent to APM, the bottom one, by, what is it? Pause. Angle, side, angle, right? Angle, side, angle. So angle, side, angle, triangle congruence there. And then GP is congruent to AP. All right, so let's go back and look. GP, right here, that's congruent to AP. Trying to do that in a slightly different color too. All right, so what is the reason for that? Well, we know the two triangles are congruent, so the corresponding parts must be congruent. Those are corresponding parts in those two triangles. So CPCTC, and then same thing for MP and RP. So here's MP and RP. Actually, we need another tick mark because there's one there, so we need to make these 2, and this is going to be 3. A lot of tick marks on here. Okay, so same reasoning. We've got these two triangles, the top and the bottom, so all the corresponding parts have to be congruent. So we can say CPCTC. All right, so what did we just do? Well, we proved this parallelogram property. Diagonals bisect each other in a parallelogram. Right? That's what we just showed, right? Because these two are congruent and these two are congruent. Those are the diagonals, okay? So diagonals bisect each other in a parallelogram. All right, so on the back, I'm gonna do the first one with you, and then what I'm gonna do is have you do it yourself, and then you can turn off the video and then come back for the answers. All right, so the first one, solve for x. You have to ask yourself, what do I know about quadrilaterals here? What is this? This is a parallelogram. What do I know about these sides? We know the sides are, you guessed it, congruent. So we can say x plus 1 equals 7. So to solve for x, just subtract 1, right? That's what they're asking us to do, solve for x. So x equals 6. All right, so go ahead and do 2, 3, 4, and come back for the answers. Pause. All right, and here are the answers for the rest of them. All right, so, whoops, this is 2, sorry. So 2, these are congruent, right? The diagonals are bisected, so if they're congruent, we can set them equal. And then we solve for x. Here we had to find the measure of angle G. I know that these are congruent, the opposite angles, so I set them equal. I get an answer of 10, but I'm not done because I have to solve for G. So you plug in 10, 5 times 10 minus 9, and you get 41. And then the last one, there's a couple ways you could do this. I knew that these are supplementary, so I just made this 145 degrees and set 14x plus 5 equal to 145 to get 10. But you could also add 35 to this and equal it to 180, right? You're still going to subtract the 35. I just did it before. So either way is correct. All right, so the notes are done. Then you can go ahead and do this day 13 homework, and you also have a Canvas practice. All right, have a great weekend, folks. See you Monday.